India's Eye on the Sun, the Aditya L1 mission. India has embarked on a groundbreaking journey to unravel the mysteries of our nearest star. The Aditya L1 mission, launched in 2023, marks India's first foray into dedicated solar observation. Positioned at a strategic vantage point, the Lagrange Point 1, Aditya L1 enjoys an uninterrupted view of the Sun even during eclipses. This unique perspective allows the spacecraft to continuously monitor solar activity and provide crucial data for understanding space weather. The mission carries a suite of 7 sophisticated instruments designed to study various aspects of the Sun, from its outermost layer, the corona, to its turbulent magnetic fields. These instruments capture images and collect data on solar flares, coronal mass ejections, and other solar phenomena that can impact Earth. One of the primary objectives of Aditya L1 is to study coronal mass ejections, or CMEs. CMEs are massive eruptions of plasma and magnetic fields from the Sun's corona that can travel at speeds of up to 3,000 kilometers per second. These explosive events can have significant impacts on Earth, disrupting satellites, power grids, and communication systems. By studying CMEs, scientists aim to better understand their origins, evolution, and potential impact on our planet. Aditya L1's observations will contribute valuable data to improve space weather forecasting and protect our technological infrastructure from the Sun's powerful outbursts. Unmasking the Fury coronal mass ejections and their earthly impact. Imagine 1 billion tons of superheated gas, a maelstrom of charged particles hurtling through space at unimaginable speeds. This is the raw power of a coronal mass ejection, a force of nature capable of wreaking havoc on our technological civilization. These solar storms, though invisible to the naked eye, can disrupt the very fabric of our connected world. When a CME collides with Earth's magnetic field, it triggers a geomagnetic storm. This disturbance in our planet's protective shield can induce powerful currents in power grids, leading to widespread blackouts. Satellites, the backbone of our communication and navigation systems, are also vulnerable to CME impacts. The energetic particles from CMEs can damage sensitive electronics, disrupt communication signals, and even shorten the lifespan of satellites. Furthermore, these solar storms can pose a radiation hazard to astronauts in space, potentially exposing them to harmful doses of radiation. Understanding and predicting CMEs is therefore critical for mitigating their potential impacts. By studying the Sun's activity and tracking the trajectory of CMEs, scientists can provide early warnings to satellite operators, power companies, and other critical infrastructure providers, allowing them to take protective measures. When the Sun strikes back historical solar storms, the Sun, while life-giving, has a tempestuous side that has left its mark on human history. In 1859, the Carrington event, the most powerful solar storm ever recorded, plunged the world into chaos. Telegraph systems worldwide went haywire, with some operators reporting sparks flying from their equipment. Auroras, usually confined to high latitudes, were visible as far south as the Caribbean. More recently, in 1989, a powerful CME crippled the power grid in Quebec, Canada, leaving millions without electricity for hours. In 2012, a massive CME narrowly missed Earth. Had it hit, the consequences would have been far-reaching, potentially disrupting power grids, communication networks, and GPS systems on a global scale. These events serve as stark reminders of the Sun's potential to disrupt our technology-dependent society. As we become increasingly reliant on space-based technologies, the importance of understanding and mitigating space weather threats becomes even more paramount. A new era of solar observation, Aditya L1 and beyond. Aditya L1 represents a significant leap forward in our ability to study the Sun and its impact on Earth. The mission's unique vantage point and advanced instruments provide unprecedented insights into the dynamics of the solar corona and the mechanisms driving CMEs. By combining Aditya L1's observations with data from other space-based and ground-based observatories, scientists are building a more comprehensive picture of space weather and improving our ability to forecast solar storms. This international collaboration is crucial for protecting our planet from the Sun's powerful outbursts. As we continue to explore and depend on the space environment, missions like Aditya L1 pave the way for a safer and more sustainable future. The knowledge gained from these endeavors not only deepens our understanding of the Sun, but also helps us safeguard our technological infrastructure and ensure the well-being of future generations.